Let's look again at the distribution of the arrival times for fire trucks arriving on a scene. It is uniform with a minimum value of 2 minutes and a maximum value of 15. So here's our minimum value 2, here's our maximum value 15. The height of this this rectangle is 1 over b minus a, which is 1 over 13. This is our probability density function. It is the height of the rectangle. Okay, so what is the probability that the fire truck will reach the scene within 7 to 10 minutes? Okay, so I like to draw a picture every time we do this. So I'm looking for a probability that starts at 7 and goes up until 10. We are looking for this area. We know the area will be equal to the length of that rectangle times the height. And we know the length will be equal to 10 minus 7. The height of the rectangle we found previously, this is 1 over 13. So the probability that the fire truck will reach the scene between 7 and 10 minutes after being called is equal to 3 over 13. We could ask about the probability that the fire truck will reach the fire in less than 6.5 minutes. So again, here's our distribution, starts at 2, goes to 15. We're looking for, here's 6.5 minutes. And if you're arriving less than that, we are looking at this area. So the probability that x will be less than 6.5 minutes, it's the same as the probability as being less than or equal to 6.5 minutes. Again, just length times height, where the length of this rectangle in between here and here, that's equal to 6.5 minus 2 times the height, which is 1 over 13. And this is 4.5, that should say 13, divided by 13. And that's approximately equal to 0.3462. If we were looking for the probability that the fire truck will take longer than 12 minutes, again, here's our rectangle between 2 and 15. Here's the value we're given, 12, and we want to know the probability of being greater than 12 minutes. So the probability that x is greater than 12 is equal to just the length times the height. The length of this is given by 15 minus 12, multiplying by the height, 1 over 13. We get 3 over 13. And we can find quartiles. Now remember what quartiles are. This is the value below which 25% of the data falls. Okay, so let's draw a picture of that. So here's our distribution between 2 and 15. There is some value, I don't know what that value is, I will call it K, but below that, 25% of the data should fall. So it's our job to find that value. And we just use what we know. We know that area, or probability, is equal to length times height. The area that we are looking for is 25, is 0.25, right, for 25% of the data. The length of this rectangle now is K minus 2. We multiply that by the height. Okay, so now all we have to do is solve for K. So I want to clear this fraction, so I'll multiply on this side by 13. You'll also have to multiply by 13 on this side. We get a new value. 13 times 0.25 is 3.25. And that's just equal to K minus 2. And then you can add 2 to both sides. So we get 5.25 is our value K. and this is the first quartile. It is the value below which 25% of the data falls. And we wouldn't just have to do quartiles, we could do percentiles, right? So if we're looking for the 60th percentile in between 2 and 15, we're looking for the value, call it K, and below there we want 60% of the data. Again, just filling in the formula, area is equal to length times height. The area that we are looking for is 0.6. The length of this rectangle is K minus 2, and the height is 1 over 13. Again, we multiply by 13 to clear the fractions. We'll do that on both sides. On the left, we'll have 7.8. That will be equal to K minus 2. And from there, then we can see, adding 2 to both sides, K will be equal to 9.8. And this is the 60th percentile.